Okay, let me start sharing screen. If you can enable me for screen sharing.
I'd have to start recording though.
Yeah, let me know when you see it. I hope you can see my screen.
Yes, we can.
Okay, I have also today a live demo, just to give some update where we are. I have also 2-3 slides to share, but after that we can switch to some more live demo setup. Let me try to switch to full screen if I can. Okay. I don't know why full screen doesn't work. Right, just as a reminder, what we were trying to investigate latest. So we are trying to introduce an attribute-based API, basically for more fine-grained kind of configuration of resources. And we are thinking to use DRA to help us schedule some of the problems, to deal with some scheduling problems for that, and also to handle the basically user interface pieces representing this as a claim, more or less. We start by putting that in a JSON format. I think Kevin mentioned that there are other ways also through CRDs. For now, we start simple just with a JSON format. We can adjust that later to a CRD format. But also as part of the KEP, we got some questions regarding what is to be spec'd out in such kind of JSON or CRD format. And here I have a little bit more information. We try to define it a little bit better. So we are thinking similar to DRA. We have some sort of names or identifiers. So basically, in this example, we have 3 pools, 3 core pools. Some core pool with 2 cores, some core pool with 8 cores, and some core pool with 4 cores. Then this is just an IDs which we can use to reference each pool in the claims by, for example, resource class argument or something like that. Then we are thinking, this is also open to discussion today, if we want to introduce something like capacity. So basically, we will have a capacity. We could have a capacity field and a cores field. Basically, capacity is something which you could think about like a pool capacity in more like a static policy way terms. So basically, you have static pre-allocated pools of maybe 10 cores. And then 20 cores, 80 cores. And then when you are claiming stuff out of the pre-allocated pools, you're using this core struct basically to pull out cores out of the predefined pools. Right. We added also some additions how the cores thing can be defined. So we could have just a single digit or a single number indicating that we, in the cases of exclusive, indicating that we want more or less to pin 2 cores. This is equivalent to pinning. Then we could have a scenario where we could ask some range, very similar to a burstable case. So basically, we could ask, we want a burstable scenario between 6 and 8 cores, basically. And here the question to community would be if it makes sense in a static policy way. Let's say if we have a burstable scenario like that, we can map that as a CPU set back to the 20 cores, which we defined in the capacity field. This is if we want to start with some static policy. Alternative here would be basically if you use, if we use actually this for an exclusive kind of access as we define here, we could think about usually in a scenario where people are requesting exclusive cores, they would actually more or less like to pin. So we could think about actually requesting the upper boundary as a CPU set. So we could request a CPU set of 8 cores and then set the CPU shares according to this range. But the other option is basically if we introduce this optional capacity field, we can set the CPU sets back to 20 or the CPU sets over 20 over a pool of 20 cores. And this becomes even more interesting with shared. So in shared kind of, for the shared pool, this most probably makes most sense. So if you have basically some small range, in many cases, the shared applications are lower priority applications. You can map them to the whole kind of pool and then just set a smaller kind of CPU share, similar. So this is one way how we could deal with that. Another way to deal with that if the shared pool can dynamically shrink, basically. If we don't have a capacity field, we could have basically reserve initially the shared pool as all available cores, what we have on the platform. And over time, if you add some exclusive kind of task, you have to shrink basically the shared pool so that you can fit the new exclusive tasks. So those are first additions, what we are thinking to introduce in the more or less the attribute-based stuff, so that we have more control. Then the other additions are we see the needs for customers and users to have some sort of selection of NUMA affinity based on devices. So this could mean also that you have some capabilities in the DRA driver which do device selection. But basically you could then specify some sort of binary option, more or less similar to a binary option, where you could tell that you need NUMA affinity with your device, you like to have NUMA affinity with your device, or you don't care, basically. And very similar with we are planning to introduce a memory attributes, which would mean basically we have two types of affinity according to memory attributes. Bind affinity, which is in Linux terms is very similar to single NUMA. So basically bind means we want closest affinity to the memory controller. And let's say required means fit everything, fit the full pool inside inside the socket, or which basically controls that memory controller. Preferred means start filling it in if the container runs over. Basically, if you need more cores than actually needed, you go to the next. So it's some sort of best efforts kind of semantics, similar to best effort semantics. And then interleaved, this is a little bit similar to NUMA spread. If you think about it, it's basically maximize memory controllers for the container. so take cores so that you can get more memory controllers. Here again, we could have required and preferred. Basically, required means if you cannot get all n memory controllers, you error out. Preferred, you get the max number of available memory controllers. Right, and then there are further attributes which we are thinking. So we will need something for huge pages. This is more long-term, not only alpha, most probably also for beta scope, as we wanted to deal with CPU first in the alpha stage. But when we start thinking about memory, those are the things what we could pull in. Then more interestingly is also CPU attributes in terms of siblings. So we could have core siblings preferred. Core siblings preferred means basically if you have a pod and container requesting several cores, you try to put them first to populate all the siblings on the physical core. Core siblings denied is interesting. This is basically you could if your container requires a core, just one core, just as an example, you block the whole sibling with that. After that, basically, this defines that you don't want to share the sibling with another core, with another process. And there are some kind of lower priority option of that, preferred and further dedicated is basically if you want one physical core will correspond to dedicated. You can have basically one process which you want to map to the full physical core. So those are some of the options which I wanted to throw in for today for discussions. I don't know if this helps a little bit to get better overview of what such an API will look like. Any thoughts? I don't know if it's useful for your use cases, what you have. I'm wondering, if you have some ideas how we can improve that, or if something is not fitting.
One question I have is the course that you have in your example there. Is it a quantity or is it like are you asking for explicit CPUs here?
So those are if you are in the classes of exclusive, or if you speak about exclusive case, those will be explicit course asks. So or it's not CPU IDs, if this was the question. So we are never asking for CPU IDs. We are asking for two cores basically, or between 6 and 8 cores.
So it's quantity essentially.
Yeah. Okay. Just to be a little bit more conform with the Kubernetes way, not to put IDs there, right? Even if some customers want, right?
Okay, thank you.
Right. Any other question?
And from my perspective, we can debate on this after we understand the full mechanism to make any of this possible. So.
Right. Yeah, I have a little bit illustration how it works, or how we think to make, or also a question. But again, to the community, this is a small scenario illustrating basically starting with some request for shared cores, 3 shared cores. So we have some information, like after that we could query how many cores are still available. So if you are using a shared pool, which does not have capacity. You have all the cores available for that, so 10 cores. And if you allocate 3, another application which wants to use shared cores can still allocate those, or can go on top of those. So that's why we are saying 10 shared cores are available. But if you are an exclusive kind of application, the idea here is not to overlap with any other pod on the system. So it means the exclusive application gets new 3 cores, and after booking a shared application, we get 3 cores less for exclusive applications. You see, I had used some index for exclusive, this case 0. I don't know if it would be a useful feature to make it possible if another application comes later, which has the same index. Let's imagine the index is the claim ID, that they can join this set, or they can join they can share the cores, similar to what you have with GPUs. It might be a possibility. I don't know if there is a need for such kind of controlled sharing. But we could do it like that. So you could go directly on the cores, which a certain claim was assigned to. Another option is actually, if you look into the second application here, it requested 4 cores. I could optimize a little bit the overlapping, avoid overlapping. So put this second core here, as this one is more, it's still free. So I could do that, but it will use more resources on the system. So we could think about such kind of options. I don't know if they will make sense, but it's something which is we could imagine, we could think about supporting or not, right? Currently, in the initial kind of scope, we are thinking to make that just exclusive. It means if you have a second application, it will be treated like X1. So it's always non-overlapping with previous applications. So just to make it clear, right? But one option here, what we could have is maybe share, do some possibility to share based on claim ID, and the shared kind of pool here. You can put anything, more or less. Any kind of claim can use the shared pool if there are cores available. Right. That's a little bit more about the initial semantics, what we were thinking about with this shared and exclusive pools. Right. So in terms of possible realization with DRA, this is also very similar to what my kind of demo would be today. Actually, nice thing about the DRA side, all this kind of fail safety concerns, and pod spec things. We actually don't need any pod spec extension with DRA, the resource class option, the CCI or the driver name. Sorry for the name here, but there is a field called driver name already in the resource class, which is sufficient. We could basically provide a second socket for the CCI manager, which will where basically we can register drivers for CCI with exactly the same name, like in the resource class, and then we can use this completely the same mechanism. And this is what I'm doing in the demo, and we'll show it working. We already started also in the prototype pulling in the latest kind of discussion points. So CCI manager is basically completely standalone. CPU manager is disabled or set to none. And currently we are using some in the prototype. I still did not implement the CRD communication back to the state to the schedule controller. I'm running just on one node. This is currently skipped in the demo, but basically you will see a DRA driver and then combined with the CCI driver. And I have two sets of callbacks. I have the node prepare callbacks as part of the DRA driver, and then I have another callback, set of callbacks, which are the admit and remove events, basically coming from the CCI handlers. One thing here is if we have the two drivers, let's say usually the way how DRA works, if you want to take scheduling decisions in DRA, you need to provide state information through some sort of CRD. We could, as our kind of drivers will more or less maintain the state, we could build a single, if those two things live in the same thread or in the same process, and basically two threads, we can build a channel between the two. It was just one thought. Currently, it's not the case. Currently, I have another kind of communication through a file, but it can be a channel or something else. If they are just
I have a question about that. So you're proposing pushing the controller and the kubelet plugin into the same binary?
No. This is just abstract box of the whole thing. I have basically two binary, or you could have two binaries, one controller binary, and I'm suggesting to put the node driver and the CCI driver implementation in the same binary. They can be two threads basically of the same binary.
I guess I just don't understand what the difference is. What is the CCI handler versus the DRA
CCI
driver for
is
CCI?
doing, basically can do the pod admission allocation of CPU and memory resources. So it's the CCI manager calls admit and remove functions of this handler. So basically, it will be this handler will be called here, and basically, if I let's say I want to allocate some pod with the new kind of spec, I will get this event, and I could send through the channel a message to the node driver that the state changed, basically. And then the node driver can share back to the scheduling through the CRD or something else.
Okay, I'm a bit confused, but maybe if you have other slides that explain this relationship a little bit better, that'll clear it up.
Yeah, this was a little bit other view of basically the CCI resource driver is the second thread. We had these three functions defined inside, basically to admit a container, a container, then to add the resource or map, do some sort of mapping between container ID and the actual container, and then remove the container. So
yeah, so the way I was picturing this working with, the extending of the concept of how DRA does things is that this would now become your interface to your CCI manager, and there is no notion of node prepare resource, node unprepare resource. This is your API. And so I guess that's why I'm confused on the other slide. What is node prepare resource and node unprepare resource doing
still
in the CCI?
So node prepare resource, node prepare unprepare resource, they are still the classical DRA driver. So if you want to do some scheduling component for this config maps for this kind of attribute based stuff, basically we can use those two functions, the node prepare and unprepare resource of the classical.
But those have nothing to do with scheduling. All the scheduling decisions happen in the controller, and all node prepare resources does is takes the claim ID, figures out what configuration you want to put on the node, and then returns a set of CDI devices back to the kubelet. Fairly straightforward what it does. And so what I pictured you were going to be doing with
Where do you?
for CI.
Mhm.
Okay.
I have a question there. You are in the node drivers. Usually, you're updating the state. Like if you are claiming something, where should we update the state? Is it? Of course, we can update it in the CCI handler stuff and then send a message back to the controller. But is it not the node driver updating the state?
Node driver updating this. What do you mean by node? So the Kubelet plugin.
So the classical DRA node driver, where you have the CRD basically with which counts your resources on the node after
Yeah.
claim.
So the classical way that DRA works is that you have, the controller piece and the Kubelet plugin piece, which runs as a daemon set.
Right.
When the Kubelet plugin comes online, it advertises all the resources it has available through a CRD. Then the controller, when it's communicating with the scheduler and trying to figure out what node a specific pod should land on that's trying to get reference to a claim, where that should go, it's consulting the CRDs that have been advertised by all the nodes that have the Kubelet plugin running on it, finding an appropriate node to do this, to put the pod on, to allocate the claim on, puts a reservation on that claim into the CRD, and then sends that back to the scheduler so that he can actually schedule it. Once the pod lands on the node, the Kubelet plugin that's running scans its CRD that it's put out, sees what reservations are there, makes sure that whatever claims being requested to have land on this node right now, that there's a reservation for it that's been put in by the controller. If there is, it goes off, configures the device the way that it's been told to by the controller, generates a CDI device for it, and passes that back to the Kubelet, and then commits that this has been allocated by writing that back to its own section in the CRD.
Right. Here, basically, I was.
And so what I was picturing with CCI, just to be clear, is that you may have something called node prepare resource, node unprepare resource. You may not. It's kind of up to you as the implementer of what it means to be a CCI plugin for DRA versus a standard CDI, if you want to call it, CDI Kubelet plugin for DRA, which is the only kind we have today. But it'd be completely up to you to define what this API back to the Kubelet was, because whatever driver name you put in your resource class, when it gets into when your pod lands on the Kubelet and it's trying to allocate claims of your type, it's going to know to call into the CCI manager rather than the DRA manager to handle these types of resources. And so the API you then define with your plugin can be whatever you want. You're not beholden to the node prepare resource and node unprepare resource APIs like the CDI.
Do I not need the standard node driver to still speak with the controller, right?
Well, you have to write your own controller. You have to do the exact same thing we're doing for CDA for a DRA driver. You're just writing one for your CPU devices.
Right, the controller, but if I use the controller given by DRA API, it will always call node prepare resource, node unprepare resource. Do you mean that?
I don't follow. Say that again. There is no node prepare resource in the controller.
Yeah, basically the DRA provides a small API to create controllers and stuff like that. This part of the staged kind of repo inside Kubernetes.
Yeah, we have helper functions. Yeah.
So if I create a controller like that through the helper functions, this controller will communicate with my drivers through node prepare resource, node unprepare.
Not for the controller. The controller doesn't know anything about the API of how you're
manager. You're right. So it's more DRA. So you are suggesting to skip, still create the controller and even not use DRA.
Yeah, so use the controller for scheduling, but now because you're in the same way that and you could even continue using the helper library for the controller to help you do your allocation, to communicate with the scheduler, to make sure that you get your resources, in your case CPUs, allocated properly to a node. But once that process is done, you can now define and decide whatever interface you want from your CCI
Okay.
manager to communicate out to however you decide to design your plugins here.
Yeah, this might be feasible. We were relying on those two callbacks from now, just from the standard DRA implementation. But we could theoretically add callbacks which will do corresponding kind of counting or communication back to the scheduler, or basically callbacks to handle the scheduler data.
So once you're on, I see what you're saying. Yeah. So again, the process that the standard DRA driver follows is Kubelet plugin comes online, advertises resources through a CRD. Controller, when he's consulted by the scheduler to figure out where to allocate resources, looks at that CRD, makes decisions, and then reserves those resources that he's allocated into the CRD, so that when the kubelet has the pod land on it, you can call out to the plugin, and the plugin can see that these reservations have been made and do whatever is necessary to allocate them. And I think that is a high-level process, is completely doable in your world. It's just that once you land on the kubelet, you don't have to follow the standard mechanisms we've decided to use for CDI-based plugins, because the types of resources you're trying to allocate are different. You don't have a notion of a CDI device you want to pass back.
That's why I have to use the channel basically currently. But with your idea, I could avoid it. Yes, if I basically make the callbacks or whatever handling I need to communicate back with the controller inside the CCI drivers. Yes, this could work with less pain, right?
Yeah, because then at least from what you have to change in Kubernetes perspective is very small, right?
Right.
All you end up having to do is you need to add the logic in the kubelet that knows how to call out to a CCI manager instead of a DRA manager based on what has registered itself with the kubelet and what the driver name of the resource class is.
This is simple as it is basically similar approach, like we are calling this events already. So we need a little bit additional to call the events which we need for scheduling, more or less. But that's all. It should be easy to integrate, most probably. Yeah, we can investigate that. See if we can get rid of the or handle it all through one entity would be nicer. Yes.
Yeah, I missed the last part you said about the said some scheduling something. What did you say about scheduling?
Yeah, I was just saying that we can take that suggestion, try to implement it like that. Basically to handle all the data calls what we need from the controller perspective in the same entity for now. We were just doing admit that, remove containers calls, but theoretically we can handle the whole kind of scheduling callbacks what we need for the attribute based stuff. Besides that, it should be doable.
Yeah, I guess I'm confused by the word callback here, but yeah, the communication between the controller and the kubelet plugin.
Yeah, they are gRPC calls, right? Yeah.
So I would highly recommend not having those communicate by a gRPC and instead asynchronously through a CRD. But that's an implementation detail.
Is this are you speaking about the way back to the controller or the way to the
both directions?
Both directions.
Having a whole bunch of gRPC connections between a centralized controller and potentially thousands of nodes that have CPUs advertising through this is not scalable. And it's unnecessary as long as you have a proper protocol between the CRD and having them communicate. And it's the way that all current DRA drivers that have been written so far operate. There's no gRPC connection between the controllers and the kubelet plugins.
But
everything is done asynchronous communication.
Yeah. If I want to have reservation similar to your reservation system, like with the prepare and prepare things routines, is this, do you see that also as a CRD, or I think that this has to be gRPC, or?
I didn't quite follow
So
part of
if
what
we
you said, but
do some sort of reservation similar to what node prepare and unprepare are
yeah,
doing.
so like I said, in the existing DRA infrastructure that we've built and that we have as best practices for building DRA resource drivers, there's absolutely no gRPC connection between the controller and the kubelet plugin. Everything is done via
I'm
CRD.
not talking
So
about the controller. I'm speaking about, okay, in this case is between DRA. I was speaking for yeah, the routines, or basically those two functions are called by the DRA manager. Yeah, it's similar if we have, and they are important for the scheduling, more or less. This is the point that I wanted to make. If we have functions which we want to call through the CCI manager, which are important for the scheduling, we can call them through gRPC, or
sure, from the kubelet, but that's just a one connection back to the kubelet and
yeah.
not potentially
This was the
controller
point.
having thousands of, but
Yeah.
I guess I was confused by the middle
Yeah.
box, gray box you have here that says gRPC. And then you talked about scheduling callbacks. And once you're on the kubelet, there's no scheduling going on. So that's where, to me,
Mhm.
if you're talking about callbacks that refer to scheduling, I would assume you're talking about some communication between the controller and the kubelet plugin. And then you said that would be via gRPC. And so I got confused.
No, here I just put it in white. White means if it's an option, but given your feedback, it's because you could theoretically have a server on each node driver and communicate with the controller, similar to what you are doing with the CRD. So you could start a server listening basically to a gRPC calls from the controller, which can be also completely asynchronous.
Yeah, I mean, of course you could. I'm just saying that it wouldn't scale if you do.
Right, right. But we were thinking in any case first follow the same path through CRD if we are communicating between the CCI stuff, or and the controller. If we are
Yeah, okay.
communicating between CCI manager and the drivers, then it's gRPC. Basically,
Yeah, yeah.
this was.
Yeah, so just looking more closely at this exact picture that you have here, then, so to be more concrete on my recommendation would be that in that middle box that you have gray, I would focus only on doing CRD communication there, not gRPC, between your controller and your kubelet plugins. And then for the kubelet plugin themselves, where you have thread 1 and thread 2, I would just think of that as being one entity, which is your CCI plugin. It communicates with gRPC back to your CCI manager, and you can define whatever you want that API to be. You're not beholden to node prepare resource, node unprepare resource. Obviously, you have to be able to process a claim, whatever that means, but it's up to you to decide what it means to process the claim at this point, rather than being stuck with the interface that the standard DRA kubelet plugin gives you.
Okay, no, this makes sense. This is a good idea. Okay, right. So yeah, that was more or less the slide part. Yeah, maybe if there are some questions, further questions. Yeah, then maybe I can take some minutes to try the live demo. Hopefully, the live demo caught this with me. We will see. I hope it's big enough. Let me try to resize it a little bit, as there are some screens. So what I have here is basically a custom-built Kubernetes, which I started one node custom-built Kubernetes. Currently, I'm still not having one entity to handle it. We will implement that. It sounds like good path to follow. What I will do basically, oops, sorry, I pressed the wrong. I closed the wrong stuff. Maybe in a short kind of explanation, I have a small test application, which is basically some, I have a resource class, a DRA resource class. I have the driver name, which is some CPU driver. And this resource class is basically claimed for that pod through standard DRA interface currently. And in here you see currently it's very simplified example, similar kind of config map struct. I want to claim 5 exclusive cores and 20 shared cores. That's the first thing. What we want to try out. I have a small driver implementation with DRA, and currently my CCI driver is also part of the same package. Basically, let me shortly show that. I did it very similar to the standard examples of the DRA drivers, but now I have 2 routines. I have currently I have 2 entities, but we will fix that. I have a DRA entity, which I start with that routine, and then I have a CCI entity, which I start with that routine. Both are called by the corresponding managers. The difference is basically the CCI drivers will be or the registration for CCI drivers will be done through this path. So through the sockets put in this path, and registration for DRA drivers is the other kind of DRA var folder. And the nice thing about it, yeah, I can use the same driver name in that case. So no need to do something new in pod spec for that. Currently, scaling piece on controller is not implemented. I'm just giving a hard-coded node, and it's just one node cluster. So the whole controller implementation is yeah, just to be able to allocate a claim basically. And as next thing, I need to copy something. So my cluster is up and running. You see that actually bootstrapping works quite nice. So I can start pods without problems, other pods. This is the first thing what I'm going to try. Start a small, let me close this window, a small kind of pod which doesn't have a claim. I have to search. Yeah, this is my small stress pod. I started that, and you see that I can deploy basically pods without issue. So this is basically going through with CPU manager none and CCI reacting to that. Now I would do the second kind of case for failing cases. Basically, if I try to instantiate my pod which has a claim without a driver, it starts and you don't see it on the cluster, and this is the actual effect which we are expecting. You will see it's under pods. I have a failing pod basically, and hopefully the reason, yeah, it's currently complaining dynamic resource allocation driver is not up and running. So we will have similar failure with one entity, basically, when we have a CCI driver which handles the claims for us. So which will fail very similarly to that. Now I can try to start the driver or drivers, and you see controller came up. It got the config map basically, and as next it sends it to the DRA node driver, which will do the reservation more or less. I still had this reservation stage. It takes some time. Hopefully it works. Right. Maybe I forgot something. Yeah, the demo effect. Demo got is not with me. Something strange. Right. And this is still under heavy development. At least the driver is quite dummy. You see, I created the class, I thought. Maybe some function which I did not implement in the DRA driver to register the deletion and stuff of class. But let me start from scratch. Something in my controller implementation is still not perfect, but this time you see basically first stage was the controller, and at some point actually it called the CCI driver. So it got the request, it translated it in some more readable form for our driver. And basically after that, it's actually triggered a search, what cores are available and so on. So I got two sets, which I can use. Basically the exclusive set, this is basically, I was requesting for, in the claim for a specific number of cores. This is the exclusive set, and this is the shared set, more or less. The true tells that this is the exclusive set, and then false is the shared set. Those are returned back to Kubelet, and Kubelet can allocate them after that. This is basically the mechanism currently. And I should have, yeah, and you see my pot got up. Yeah, the issues before most probably are something with the resource class. Kind of handling on the controller side, I'm missing some implementation detail because the controller is very dummy, right? But yeah, that was the demo, what I wanted to show today. Yeah. Any questions? Was it useful a little bit to see at least the bootstrapping? And we are still not ready with the checkpointing. part, so it's not included in this prototype. So I have to take a look on that side for checkpointing and stuff like that. But a lot of the other aspects are already in.
Thank you for the demo. I think it will be helpful to start consolidating the last changes you made and the new direction you're following in the CAP to help to make sure there is the track record. I mean, doesn't need to happen this week, but in general, it could be good. So we can move forward more effectively as a community, I believe. Thank you.
Yes. Well, this is on our to-do list. Is next. Yes. Yeah. Well, that was all what I had for today. Thank you, everybody, for attending, and thank you for the tips and suggestions. I think they're very good, and we will take them into account.
Thanks. Bye.
Thank you. Bye.
Thanks.
Thank you. Bye-bye.